Hello, everyone, and welcome back to the FUNWAVE application on the Irregular HPC Portal. This tutorial will focus on the third tab in our simulation workflow, the Inputs Outputs tab, and more specifically, we'll look at this Wavemaker field. In this video, we will go over the types of wavemakers available in FUNWAVE and their associated input parameters for each. So this is the fourth video in our FUNWAVE Portal video tutorial series. Please be sure to check out the introductory videos describing this platform, as well as the previous tabs, the bathymetry and topography tab of this portal. Now, there are two main types of wavemakers available in FUNWAVE. One is an internal type wavemaker, and the other is a left boundary or boundary type wavemaker. In this current version of the HPC Portal application, you will only have access to the internal type wavemakers. Now, if you are an advanced user and have a need to use the boundary type wavemaker in this portal, there is an option to manually modify the input file of an individual simulation before submitting the job. Please use caution when pursuing manual modifications, as these inputs are not checked prior to submission. To learn more, check out the 9th video in this tutorial series covering the Run tab of this portal. So there are several options available for the Wavemaker type, the options for these internal wavemakers. The first option is to not include a wavemaker in the simulation at all. So this option would be ideal in the event that you have initial conditions that you've provided to the model, such as surface elevation and horizontal velocities in U and V, or X and Y, respectively. Or if you're using the shipwakes module, for example, and you would need to generate waves exclusively from a moving vessel. So in this case, that would be the type that you would select. Now, the remaining options in the drop-down menu here will generate waves from this internal type wavemaker. And these options include an initial solitary wave, an initial rectangular wave, regular waves, which are just monochromatic waves at a single frequency, irregular waves generated using either the JONSWAP spectrum or the TMA spectrum. And these options will change slightly depending on if your simulation is in 1D or 2D, the options that you would have available. In this example, we're generating a 2D simulation, so the 2D options will be available in what we go over today. There's additionally the options to provide an FFT of a time series of wave observations or a file containing 2D directional spectrum data. The latter option is only available for 2D simulations. So let's look at each of these options more closely, starting with the initial solitary wave. So if we click on that Wavemaker type, once the Wavemaker is selected, the input parameters associated with this Wavemaker type will appear in this space below. Next to the Wavemaker type for each is this Wavemaker C-break parameter, which really just specifies the frictional dissipation at the Wavemaker location. And this would be useful in the event that waves are large enough that you'd like to dissipate them right at the Wavemaker. Now, remember that you can always read more about each parameter by hovering over this info icon to the right here. And clicking on this icon will direct you to the FUNWAVE Wiki, specifically pointing out the parameter that you clicked on and highlighted, so you can read more. Going back to the portal, we see that in the space below the Wavemaker type, our next two parameters are Wavemaker coordinate X and Wavemaker coordinate Y, and these just specify the location of the Wavemaker in X and Y in the domain in meters. These values must be greater than 0, meaning that the Wavemaker of this type cannot be placed on the boundary. Now, if you were to enter 0 in here, note that the portal will send you a warning if a value is not appropriate for a specific parameter, and that is shown via this red text here. So we'll just make these positive numbers right now. Next is the water depth at the Wavemaker location. This is also in meters, as well as the amplitude of the solitary wave in meters and the lag time here in seconds. Now, this lag time controls how much time passes between the start of the simulation and the generation or start of the solitary wave in the numerical domain. So the next Wavemaker type is the initial rectangular wave. This Wavemaker type has similar input parameters as the solitary wave, where here XC and YC specify the Wavemaker location, amplitude is specified here, and the width of the rectangular wave is provided here in meters. Moving forward to regular Wavemaker for generating monochromatic waves. Here we have these parameters populated down here. Some basic setup of the Wavemaker location in the domain in X and Y. Of course, if you're setting up a 1D simulation, the Wavemaker location would only need to be specified in the X direction. This Y direction would not appear. Again, you'd specify the water depth at the Wavemaker location in meters here. And next you would specify the period and amplitude of the monochromatic wave in these fields respectively. Now, this delta parameter specifies the width of the Wavemaker. This is the default value provided here, which is appropriate for most general cases. This is not a physical unit at all. A good rule of thumb with this parameter is that the longer the wave you're trying to generate, the bigger this delta value should be. For example, for wavelengths on the order of several hundred meters, this value should be increased up to 2 or 3. Now, again, refer to this info icon and subsequently the wiki for more information on this value, on this parameter. So next, the theta parameter specifies the main direction of the waves, where a value of 0 is shore normal. Next is the time ramp, which is very similar to the solitary wave lag time, where the waves would be delayed the specified amount of time after the simulation has started. Lastly, the Y width parameter specifies the width of the Wavemaker in the domain in the Y direction. Generally, this value would have a default value of very large, and that's something that you would see on the wiki as well. This default value is large in order to cover the entire width of the domain larger than n globe, for example. However, this option is provided in the event an advanced user has a need for the Wavemaker to be a subset of the domain. So the Wavemaker could be of a width smaller than the entire size of the domain. So moving forward to irregular waves, we have the option to generate waves using the JONSWAP spectrum. Now, there's a lot more options available for this type of Wavemaker. So going through each parameter here, again, we have the location of the Wavemaker in X and Y, the width of the Wavemaker, the water depth at the Wavemaker location, as well as the time ramp or that time lag. Now, these are all the same or similar parameters that we've seen of the other Wavemaker types up to this point. Now, for irregular wave-specific parameters include gamma. Gamma is the peak enhancement parameter for wave spectra. The default here is going to be 3.3 for a JONSWAP spectrum, so you wouldn't need to change that default value. The theta peak is the peak direction of the waves, similar to theta from the regular Wavemaker. N theta is the number of bins in the directional space to use, and N freq is the number of bins in the frequency space. These default parameters are generally 24 and 45. Normally, these default parameters will show up in your simulation. And again, you can always hover over that info icon to learn more about these parameters on the wiki. In some cases, more advanced users or more advanced simulations might benefit from adjusting these values, so please feel free to check out that wiki to learn more. Next is the frequency peak, which as it suggests, is the peak frequency of the spectrum, and that's followed by the minimum and maximum frequency cutoffs for that spectrum. Lastly, we again specify the width of the wavemaker. Again, larger values are recommended for very long waves. And here is the HMO, or the significant wave height of the spectrum that you would specify here. And then lastly is this equal energy checkbox to control whether the spectrum is equally distributed by energy, if this is checked, or by bin size, by frequency bin size, if unchecked. So this parameter is slightly more complex, and I do advise users to review the wiki for more details on what this parameter means for your input wave spectrum. Moving forward to the TMA wave spectrum. This wave spectrum includes most of the same parameters from the JONSWAP spectrum. Really, the primary difference is this gamma TMA variable. This has moved down to the bottom row. And for a TMA spectrum, this peak enhancement parameter gamma should be a default of 5. Moving forward to user-provided wave data, we have this time series Wavemaker option. This Wavemaker type expects a file containing an FFT of a time series with wave period, amplitude, and phase data. So I do definitely highly recommend reviewing that wiki for more details on what must be included in the file. We can go to the wiki here, and it will bring us to the Wavemaker specification. We'll want to go to the base Wavemaker specification and scroll down to the time series. And here you'll find some information on what needs to be included in that wave comp file. And this will be chosen from your local machine. The remaining variables, here you'd specify the number of components or rows in that file you provided. And similar to the previous Wavemaker types we've covered, you'd also specify the peak period, the water depth at the Wavemaker location, the location of the Wavemaker in X and Y in general, as well as the width of the Wavemaker in physical space and not physical space. Lastly, the final internal type Wavemaker option available in FUNWAVE is this user-provided 2D directional spectrum data. Similar to the previous Wavemaker type, a file is expected to be uploaded to the portal. Now, this file must contain similar components as the time series option. And again, let's check out that wiki to see what specifically needs to be in that file and how it should be formatted. And it'll bring us to the same location. We want to go to that Wavemaker specification. And in this case, we would look at this option. Here you provide an example of how the file is expected to be formatted, information that needs to go in it, as well as an example of where you can find and work with this type of file for this type of Wavemaker. Jumping back to the portal. Again, once that file is selected, we'll have to specify the location of the Wavemaker in the domain, the water depth, and the width parameter for the Wavemaker. Now, these are all of the available internal type Wavemakers available to you in the portal application. And this concludes our tutorial of that Wavemaker field and the Inputs tab. We do hope that this was helpful. Always remember to save your changes with the Save button on the bottom of this page. And if you do have any questions, be sure to check out that wiki for more information, join our mailing list, or contact us via email. Happy modeling!